Synthetic division. Suppose we want to divide the polynomial 2x squared plus 9x plus 10 by x plus 2. Sometimes we just want to see what it equals, but very often we would do this to see if x plus 2 is a factor. When we did polynomial long division, we saw that if the remainder, which we will call r, if the remainder is 0, that would mean yes, x plus 2 is a factor. Now, is there a way to divide this out, especially if we have a linear term in the denominator, where we don't have to do long division? And the answer is yes. So if x plus 2 is a factor, that means that I could write 2x squared plus 9x plus 10 as x plus 2 times something else, which would give us 0, which means that if x plus 2 equals 0, then x equals negative 2 is a solution, also known as a root or a 0, of my polynomial. We're going to use something called synthetic division here, where we take the potential solution, x equals negative 2, and put it in a box. And then we're going to take the coefficients of our polynomial up here in the numerator and place them just like that. 2, then 9, then 10. If there is a missing x power in here, for example, we would need to put a 0 for that coefficient in the missing x power. We'll see an example of that later on. But for now, let's finish off this synthetic division. It's a process where we get it set up, and then we simply bring this first number down. I'll just put it there. So that 2 just goes down, becomes a 2. We're now going to do a process of multiplying, placing, and adding. You'll see what I mean. We're going to take our potential solution, x equals negative 2, multiply it by this 2 to give us negative 4, and we'll place it right here beneath the 9. So multiply, place, and now we're going to add. 9 plus negative 4 gives us 5. We're going to repeat. Take our potential solution, negative 2, multiply by 5. We'll place it right here, and then we'll add. And we get 0. This is our remainder. Since our remainder is 0, it tells us that x plus 2 is indeed a factor, and x equals negative 2 is indeed a solution or a root or a 0. There's a little bit more information we get out of the synthetic division. Notice that when we divide 2x squared plus stuff by x plus stuff, looking at these highest powers, we would get 2x plus some stuff, potentially anyways. So that tells us what happens over here, or how to interpret these numbers. Since we divided an x squared by an x, the highest power left over should be an x to the first. And this will be the coefficient of the highest power that's left over, so a 2. And then we go down to our next power of x, so x to the 0, where this is the coefficient of that one, so plus 5x to the 0, or simply plus 5. Which tells us, since x plus 2 is indeed a factor, we could have written our polynomial like this. 2x squared plus 9x plus 10 equals x plus 2 times 2x plus 5. And that equals 0, not only at x equals negative 2, which we already knew, but also at x equals negative 5 halves. Let's do another example. What if we want to divide 2x cubed plus 13x squared plus 17x minus 12 by x plus 4? And we wanted to do this to determine if x plus 4 a factor which means we're trying to see if x equals negative 4 is a solution or a root or 0. Let's do synthetic division. Since negative 4 is the potential 0, we'll put that up here in our box and start placing our coefficients, starting with our 2 for the highest power of x cubed. There's a coefficient for x squared, and one for x, and one for the constant term. We'll put our bar and we'll do our process of bringing this first number down, whatever it is, and then we're going to multiply this times this. Negative 4 times 2 gives us negative 8. Place it right there and then add down. 13 plus negative 8 gives us 5. Then we keep doing it. Negative 4 times 5 will multiply, place it, and then we'll add. One more time, negative 4 times this number times negative 3 gives us 12, place it, and add. And we get the remainder there is 0. So x plus 4 is indeed a factor. X equals negative 4 is a root. So I could write the polynomial up here as x plus 4 times what's left over. Now, how do we interpret this? Well, if we divide an x cubed term by an x term, the highest power left over is an x squared. What's the coefficient of that highest power? What's the first number there? So a 2. And then we have our x to the first term, whose coefficient is 5, and then our constant term, which is negative 3. At this point, we could try to factor our leftover quadratic, and that's really the goal often when we're dividing polynomials or trying to find zeros or roots, is to somehow get it down to a quadratic. Because at this point, either we can factor it, which I'll try right here, or if not, then we can use quadratic formula. But I will see if we can factor it, and it looks like we can. And we get these 3 factors, which means I can get all the solutions to the polynomial, that is all the zeros. We already know that x equals negative 4 is 1, but we also get x equals 1/2, and then x equals negative 3. One more example. What if we want to divide 3x cubed plus 6x minus 2 by x minus 1? So we're trying to see, is x minus 1 a factor? We'll see. Which means, is x equals 1 a root or a 0 or a solution? Which means we'll put the potential solution, x equals 1, up in the box, and then put our coefficients. 3 goes with the highest power of x cubed. Then I have a 6 and a negative 2. But notice I left space. There is no x squared there, so that means it's a 0x squared, and I need a coefficient for that as well. So I'll put a 0 down, because I need a coefficient for every power, starting with the highest going down to the constant term. Bring our bar, we know the process, bring the 3 down. Then multiply those 2, place it there, and add. Multiply these 2, place it here, and add. Multiply these 2, place it here, and add. That is our remainder. It does not equal 0, so x minus 1 is not a factor. X equals 1 is not a root. But I could still write this. I could write 3x cubed plus 6x minus 2 over x minus 1 equals, let's interpret this here, x cubed divided by x will leave us with an x squared term. So my highest power is x squared, and its coefficient right here is 3. Then my next power, x to the first, coefficient is 3 again. My constant term plus my remainder of 7 over x minus 1.